We are looking at the grade 11 November 2015 paper 2, and it's a question on redox reactions. The first question asks us to define the term reducing agent with reference to electron transfer. And we know that a reducing agent is a substance that itself undergoes oxidation. And we know that oxidation from oil rig, oxidation is loss of electrons. So it undergoes loss of electrons or oxidation, and that would make the oxidation number increase. Oxidation number increase. Because if a substance loses electrons, then that would make it more positive, and it would have a more positive oxidation number. From the above equation, write down the formula of the reducing agent, the formula of the oxidizing agent, the reduction half reaction, the oxidation half reaction, and the balanced equation. Now to do this, the first thing we would do is we would look at the two substances involved. So we can see that we've got iron, Fe2+, and it becomes Fe3+. We can see from this reaction that Fe2+ becomes Fe3+. So that's the first thing that we're looking at. And on the other side, we can see that we've also got chlorine gas, which undergoes a reaction and becomes Cl-. So we're going to look at the oxidation numbers to determine what is happening. And we can see that iron from 2+ to 3+, it is becoming more positive. Its oxidation number is increasing. And that tells us that it undergoes loss of electrons, which we call oxidation. So this is very important to determine which substance undergoes oxidation. And if I look at chlorine now, I can see that chlorine, its initial oxidation number was 0, because from our laws we know that the oxidation number of an uncombined element is 0. And after it undergoes a reaction, it becomes Cl-. We can see that it is becoming more negative. And this indicates to us that it gains electrons. And we know from oil again that reduction is gain. So this tells us that chlorine undergoes reduction. So this is the first step where we've determined which substance undergoes oxidation and which substance undergoes reduction. We're now going to look at the table of reduction potentials to help us to find our oxidation half reaction and our reduction half reaction. Now, if we look at this table is called a standard reduction potential table. And all our forward reactions are reduction half reactions, and all the reverse reactions are oxidation half reactions. So if I'm looking for iron Fe2+, I'm looking for a reaction that involves Fe2+ and Fe3+, and that reaction must undergo oxidation. So that would mean that I would choose the reverse equation. So when we're looking at the table, we can see here at 0,77, we've got an equation of Fe3+ and Fe2+ that are linked. Now remember, we've already determined that Fe2+ undergoes oxidation. So we're going to choose the reverse reaction, because on this table, all reverse reactions are oxidation and all forward reactions are reduction. So when I write the oxidation half reaction, so I would say oxidation half reaction, and I would write it in reverse. So I would start with Fe2+, plus, and then I would have a single arrow, and that would give me Fe3+ plus electron. And that is the oxidation half reaction for iron. Now to get the reduction half reaction, we are looking for a reaction that involves chlorine gas and chlorine ions. And we can see here at positive 1,36, we can find that reaction. We already determined that chlorine undergoes reduction. And remember, on this table, reduction reactions are forward reactions. So I'm going to write this in the forward direction and change the double arrow to a single arrow. So the reduction half reaction would be the forward reaction when chlorine plus 2 electrons, single arrow, form chlorine minus ions. And that is how we would get the oxidation half reaction and the reduction half reaction. And to determine whether you have actually done it correctly, you would make sure that you've got the electrons on opposite sides. So you can see that for Fe, we've got the electron on the right hand side of the arrow. It's losing electrons. And for chlorine, we've got the electrons on the left hand side, showing us that it's taking in or gaining electrons. Now we would need to find the oxidizing and the reducing agents. Now if you look at the table, you can see here it says oxidizing ability increases as we go up. Oxidizing ability would also mean oxidizing agent. And we can see that it is iron that undergoes oxidation. So from here we are going to get a reducing agent, but from the chlorine side that undergoes reduction, we are going to get an oxidizing agent, because we know that a substance that itself undergoes reduction is an oxidizing agent. So that means either Cl minus or Cl2, one of these are going to be our oxidizing agent. So because the table shows us that on the left hand side of the table we've got oxidizing agents, that means on this side closest to this arrow lies all our oxidizing agents. So for chlorine it would be Cl2, because Cl2 is closer to this line. So our oxidizing agent is Cl2. To get our reducing agent, we look at the substance that undergoes oxidation. So the reducing agent would come from iron. It would either be Fe2 plus or Fe3 plus. So when I go to the table, I can see on the right hand side of this table, we can see that there's reducing agents going downwards. So you can see it says increasing reducing ability or reducing agent. So I'm just coloring this in blue. So that means everything on the right hand side of the table closest to this line where it says reducing ability, those would be reducing agents. So when I look for Fe equation, I can see that it is Fe2 plus, which is closest to this line. So that would make the reducing agent Fe2 plus. Now to get our balanced equation, there's only one major rule here when you are getting your net cell equation, and that is we need to make sure that we have equal number of electrons on both sides of the equation. Now we can see that for iron we've got 1 electron, but on chlorine side we've got 2 electrons. So we would need to multiply our iron equation by 2, and remember we would multiply each term by 2. And by doing that, we've now got an equal number of electrons on both sides. Now to get the net cell equation or the balanced equation, we would now add everything that's on the left hand side of our arrow. So on the left hand side, we've got 2 Fe plus, 2 Fe2 plus, and this side we've got chlorine. And the 2 electrons on the left hand side and 2 electrons on the right hand side would cancel. On the right side of the arrow we have 2 Fe3 plus and we have 2 Cl minus, and that would be the balanced net redox reaction. I hope you found this video beneficial. Please like if you did and subscribe so that you don't miss future videos, and share this video with your friends so that more people can benefit from these lessons. Agent.